Let's explore how to synchronize files using rsync. Rsync is a powerful tool used for efficiently transferring and backing up data. We will cover advanced techniques to help you master data synchronization and backups. Rsync is a fast and versatile tool for copying files. It efficiently synchronizes files and directories and employs a delta transfer algorithm, which means it only transfers the differences between the source and destination. Rsync can work locally or over remote connections and preserves permissions, timestamps, and other attributes. Here's a basic example of rsync syntax. The command rsync followed by options, then the source, and finally the destination. For example, to copy files from a local directory to a remote server, use the command rsync with the options archive, verbose, and compress, then specify the source directory and the user at remote : the backup directory. Let's explore some commonly used rsync options. The archive mode, represented by the flag A, preserves permissions, ownership, timestamps, and enables recursive copying. Verbose mode, represented by V, displays detailed information about the transfer process. The compression option, Z, compresses file data during transfer to reduce bandwidth usage. The progress option, P, shows progress during transfer and enables partial transfer resumption. The delete option, represented by delete, removes files in the destination that do not exist in the source. And finally, the dry run option, N, shows what would be transferred without making any actual changes. Here are a few basic rsync examples to get you started. For local synchronization, the command rsync, followed by the source path and the destination path, copies all files from the source to the destination, preserving attributes and showing progress. For remote synchronization, the command rsync, the local directory, then the user at remote host : the remote directory, transfers files to a remote server with compression for faster transfer over networks. And finally, to pull files from a remote server, the command rsync, then the user at remote host : the remote directory, followed by the local directory, downloads files from a remote server, displaying progress and allowing you to resume the transfer if needed. Let's discuss some advanced rsync techniques. One useful technique is filtering with include and exclude rules. To exclude specific file types, use the command rsync exclude equals ***log**, then the source and destination directories. To include only specific file types, use the command rsync include equals ***txt*, exclude equals ***, then the source and destination directories. These commands allow you to control which files are transferred using pattern matching rules. Another useful technique is bandwidth limiting. To limit bandwidth to 1000 kilobytes per second, use the command rsync limit equals 1000, followed by the source and destination directories. You can also limit bandwidth with compression using the command rsync limit equals 500, followed by the source and destination directories. Another technique is backup with timestamps. To create backups with a date suffix, use the command rsync backup dir equals backup, open parenthesis date plus %y minus %m minus %d close parenthesis, followed by the source and destination directories. And finally, dry run testing. To preview what would be transferred, use the command rsync delete, followed by the source and destination directories. To show only changes that would be made, use the command rsync itemize changes, followed by the source and destination directories. This allows you to safely preview changes before executing the actual transfer. Let's learn about incremental backups with rsync. Incremental backups store only the changes made since the last backup, which saves space and reduces transfer time. This method offers efficient use of storage space, a faster backup process, the ability to restore to specific points in time, and reduce network bandwidth usage. Rsync can create incremental backups using hard links to previous backups, making each backup appear complete while only storing the changed files. Here is an example. First, create a dated backup directory using the variables backup directory equals /backup/ open parenthesis date plus %y minus %m minus %d close parenthesis, and latest link equals /backup/latest. Then, perform an incremental backup with hard links using the command rsync delete linkdest equals $open brace latest link close brace, followed by the source directory and the backup directory. Finally, update the latest symbolic link using the command lnnsf, followed by the backup directory and the latest link. Let's see how to use rsync over SSH for secure file transfers. rsync can use SSH as its transport mechanism, providing encrypted and secure file transfers between systems. This method offers encrypted data transmission, authentication using SSH keys, requires no additional services, and works through firewalls on port 22. A basic rsync over SSH command looks like this: rsync, followed by the local path, then the user at the remote path. Customize SSH connections for specific requirements such as non-standard ports, identity files, or compression settings. To use a specific SSH key, use the command rsync /ssh /ssh/id_rsa followed by the local path and the user at the remote path. To use a non-standard SSH port, use the command rsync p2222 followed by the local path and the user at the remote path. To limit SSH bandwidth, use the command rsync limit equals 1000 SSH, followed by the local path and the user at the remote path. Let's explore how to automate rsync with Cron. Cron allows you to schedule rsync commands to run automatically at specified intervals, ensuring regular backups without manual intervention. Here are the basic steps. First, create a backup script with your rsync commands. Second, make the script executable using the command chmod +x. Third, edit the Cron tab to schedule the script. And fourth, test the automation and verify the backups. Here's an example of creating a backup script. Start by creating a file named backup.sh with the following contents: shebang/bin/bash. Then, define a backup directory using the variable backup directory equals /backup/ open parenthesis date plus %y minus %m minus %d close parenthesis. Next, use the rsync command with the options archive, verbose, and compress and delete, followed by the source directory and the backup directory. Finally, make the script executable by running the command chmod +x backup.sh. The cron tab file defines when your backup script will run. Use the cron tab editor to set up your schedule. To edit your cron tab, type the command cron tab -e. Here are some examples of cron jobs. To run a daily backup at 2 a.m., add the following line: 02 ****, followed by the path to your backup script and redirect the output to a log file using the greater than symbol /var/log/backup.log2 greater than in 1. To schedule a weekly backup on Sunday at 3 a.m., add the following line: 03 ***0, followed by the path to your weekly backup script. And to schedule a monthly backup on the first of the month at 4 a.m., add the following line: 041 ***, followed by the path to your monthly backup script. Here's the cron format: minute, hour, day of month, day of week, and then the command. Let's discuss rsync performance optimization. Using compression wisely is important. Compression, indicated by the option Z, can speed up transfers over slow networks but might slow down transfers on fast networks or with already compressed files. Use the command rsync, avs for compression, or rsync without compression, depending on your network and data type. Limiting file scanning can also help. Use the option files from to specify exactly which files to transfer, reducing the time spent scanning directories. First, create a list of files to transfer using the command find source / name ***, JPG greater than files to transfer.txt. Then transfer only those files using the command rsync files from files to transfer.txt, followed by the source and destination directories. Increasing transfer speed. Modify the rsync algorithm and block size to optimize for your specific use case. Use a larger block size for large files with the command rsync block size = 2048, followed by the source and destination directories. Use a faster checksum algorithm with the command rsync checksum choice = xxh128, followed by the source and destination directories. And finally, consider parallel transfers. For multiple directories, run multiple rsync processes in parallel to utilize available bandwidth. The command rsync source / directory 1 / destination / directory 1 & followed by rsync source / directory 2 / destination / directory 2 & and rsync source / directory 3 / destination / directory 3 &, then type wait to run the processes. Let's review some rsync best practices and summarize what we've learned. Always test with the dry run option represented by N before executing critical transfers. Use checksums indicated by checksum for critical data verification. Create backup scripts with proper error handling and logging. Implement bandwidth throttling during business hours. Use exclude patterns to skip unnecessary files. Set up SSH key authentication for automated transfers. Monitor and log rsync operations for troubleshooting, and regularly verify backup integrity with test restores. In summary, rsync is a powerful tool for file synchronization that efficiently transfers only the differences between source and destination. Key advantages include delta transfers, bandwidth control, preservation of attributes, and secure transfers via SSH. Advanced techniques like incremental backups, filtering, and automation make rsync suitable for enterprise backup solutions, and proper optimization can significantly improve performance for large transfers and reduce system resource usage. For additional resources, refer to the rsync manual page by typing man rsync in the command line, or visit the official rsync website at rsyncsamba.org and check out the Linux documentation project guides. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.